Hi, welcome to the GPS LoRa Trackers team's demo video. Our ECE team consists of Alan Jin, Alan Ko, Christina Zhao, and Sheil Bardwaj. The motivation for our project is to create an open source and high-performing solution for livestock tracking on rural farms. The technology our trackers use to communicate with is called LoRaWAN. This type of network has a much wider range compared to Bluetooth or Wi-Fi. In this video, we'll show you how our project works and show you a quick demo.
This is our senior design project. This is a tracker that we've made. It uses an Adafruit Feather M0, which has the LoRa radio component on it. It also uses the Adafruit wearable GPS for GPS signals. The custom PCB board connects the two using a hardware serial connection. And we use a LiPo battery of 500 milliamp hours to power everything. This battery ends up with a battery life of around 1 to 2 months, depending on the interval which we wake up. And this antenna here leads to a range of around 1 kilometer. So we put all of this inside of the casing here, which is just a simple box with a hole for the antenna with some screws. Put it in. And then obviously it'll screw together shut. So the tracker will wake up whenever it, every 30 seconds is what it's set to right now, look for a GPS fix, and then send the signal.
So this is our T2Go T-Beam gateway, and it is the always-on component of our project. And when it's plugged in, it is programmed to receive any incoming LoRa signals that could be sent from various trackers. And as you can see, it's connected to the Wi-Fi when it's plugged in as well. So it has the ability to upload the information to a cloud database, and we're using MongoDB for that. And from there, the user interface can pull from it and display the information on a map, as you'll see later. And this T2Go T-Beam gateway can also pull information from MongoDB from the user interface to update the ping interval time of any one of the trackers that you.
This is our client-side facing UI that's built on the Next.js framework. Basically, what this does is interfaces the client with our MongoDB backend and allows them to view real-time tracker data right from here. And so just to talk about some of the features, we have the main dashboard, which is what you see when you load into it. And it allows you to click on the tracker or click on markers and then view which tracker it's referring to. And then on the left panel, we have the more detailed information about each tracker. So we get to see its last seen location, date and time, and then its current status. So is the tracker in good health? Is it in range? Stuff like that. And then finally, we get to change the ping interval, which is how often you want the tracker to send data to the gateway. For now, Analytics has the option to check the heat map. So basically, as you collect readings, it shows color densities that correspond to like where the tracker's been. So like in certain locations where it goes more often, it'll be a denser color.
So this is the live outdoor demo of our tracker in action. We have our T2Go gateway beam set up and the user interface pulled up, which will show us live updates of the tracker location. So we have 3 different trackers plugged in, and Christina and Allergen will walk our trackers out to tech green. When a GPS fix is found, the location will be updated on our user interface. So here, along with the gateway, we have a serial port connected that shows the messages that the gateway is receiving from the trackers. So the first thing that shows up on our serial port is the gateway saying, cannot get a fix. This is an error message that pops up because the GPS module doesn't work indoors. Now, as we're walking out onto tech green, we should get a ping. The ping interval that we have set right now is 30 seconds. That means every 30 seconds, our GPS module and LoRa radio will wake up and then send a ping to the gateway. That interval can be customized to longer lengths, but we have a shorter length right now to test. So looking at our UI, we have 3 updated markers. The markers are labeled with the respective IDs, and the locations are very accurate to the actual locations of the trackers, which is 3 points around tech green. In this clip, we are showing the tracker information that's shown on the UI. The trackers send the coordinate locations as well as the date and time. The ping that we just got up from our trackers matches the current date and time. The Google Maps API allows us to zoom in and out, change the map to view the terrain, or switch the view to satellite view. So every time the trackers need to send a ping, they try to get a GPS location fix. After successfully getting the GPS data, they send it to the gateway using LoRa. After the gateway receives the data, it uploads to MongoDB, our cloud database, and the UI retrieves the data from the cloud database and updates the user interface. Thanks for watching our demo video. To learn more about our project, visit our website. The GitHub and other project deliverables are all linked on the website.